Well, hello and welcome. My name is Eitan Suez, and in this video, we're going to go through a an exploration I did with Spring and Spring applications and microservices and Istio together. So the title of this presentation and demo is Deploying Spring Boot Applications on Istio. So it's Spring on the left-hand side, meet Istio on the right-hand side. So first of all, hello and welcome. My name is Eitan Suez. I'm responsible for training and education at Tetrate. And I, at Tetrate, have a variety of sort of related roles pertaining to education, conducting workshops on Istio, and training our clients on enterprise service mesh and specifically Tetrate Service Bridge. Previously, I worked at VMware and Pivotal. All right, so this webinar is all about a walkthrough of an exploration I did recently, having to do with applying service mesh to a set of Spring Boot microservices. So specifically focusing on the Spring sort of ecosystem. The duration of this webinar should be approximately an hour 15, give or take. It might be a little bit longer, we'll see. We encourage your participation and welcome your comments, and also encourage you to join our Tetrate Slack community, where you can ask questions about this webinar and anything related to Service Mesh and Istio and Envoy. So let's begin. Let's start by properly discussing maybe a little bit of the history of the background of the Spring framework. It's a very popular open source framework for JVM languages. It needs no introduction. It was created almost 20 years ago, I want to say, and over time it's just kept on growing in popularity and scope. Spring is used today by very many large enterprises who often standardize on Spring and Spring Boot as sort of the technologies for building cloud-native applications. So how Spring has evolved over the years is an interesting thing because it started out as solving a very specific problem in having to do with building web applications or applications in Java in general. And it offered a solution called the dependency injection. It was originally called inversion of control, if you'll recall. And over time, its scope expanded to sort of build on that foundation to support building web applications with the Spring MVC framework, which was sort of an addition to the Spring ecosystem and sort of taking into account also taking over the responsibility of managing your data access to a backend database or whatever type of data store your application may be using. And there are different Spring Data projects that sort of, what's the word, that pertain to that. And then in other facets of application development, you saw sort of an offering from the Spring community or an integration with a popular library. So Spring Security sort of came into being that supported various aspects or facets of security. Now, at some point in time, Spring Boot was introduced, which was sort of a major sort of step function in that Spring Boot is defined as an opinionated framework that leverages conventions for auto configuration, but it also inverted sort of the role that up until then, JVM languages, you would deploy WAR files perhaps or EAR files onto an application server or a web server, and that role sort of inverted, and you had more of an embedded Tomcat inside your web application. And that's some of the things that Spring Boot sort of brought to the table. The simplicity through conventions of starting an application that leveraged all of the capabilities of the Spring framework, and through conventions and annotations primarily, it became a matter of assembling your applications by selecting a list of dependencies and turning on features through what we call auto configuration. So Spring Boot was instrumental in facilitating accessing many of Spring's underlying features and making Spring really accessible and really simplified or facilitated adoption. So we saw a great deal of adoption of Spring thanks to Spring Boot. And as we move forward in time, then what you see is the Spring ecosystem sort of tacking on another responsibility. There's the Spring Cloud umbrella term for a whole family of projects that deal with cloud native computing. And it began perhaps with sort of looking at what some other companies were doing, namely Netflix was quite an influence, and improving upon some of that work and sort of creating Spring Cloud projects around it. And Spring Cloud over time grew to encompass solutions that sort of span beyond its original scope, supporting a variety of different cloud providers and different types of cloud native issues. So, for example, dealing with ingress, Spring Cloud Gateway sort of came into its own. Dealing with resilience, there's a Spring Cloud Circuit Breaker, I think, which is based on perhaps a variety of different options for resilience. Resilience 4J is a library that comes to mind there. So Spring Cloud has become a staple, sort of in the ecosystem. It's had some successful adoption, and it's used fairly widely in the enterprise today. Now, the way these Spring Cloud projects work, it's essentially a matter of applications choosing to include a variety of dependencies to unlock a capability. So the model is you add a dependency to your application, and there has to be some coordination between multiple microservices using the same common, for example, service registry. So whether you're using console or Eureka, you would need the Eureka client, for example, if you're using Spring Cloud for load balancing a request to multiple instances of another service. That builds on top of that service registry capability. Ribbon is typically one of the options, or one of the underlying libraries that was sort of assimilated into the whole Spring ecosystem. And again, the list goes on. There are different libraries for different purposes. I mentioned Spring Cloud Gateway and Spring Cloud Circuit Breaker. You bring in those dependencies. Sometimes there's configuration or enabling a feature through an annotation or configuration that allows you to configure that capability. All right, so that's Spring, the sort of left-hand side. Let's talk about the right-hand side. Let's talk about Istio. Istio is a relatively newcomer to the equation, right? Kubernetes was introduced relatively recently from the point of view of the timeline of the evolution of the Spring framework, and then Istio on top of it. And with Istio, there's sort of an inversion of control there. Applications no longer need to be environment aware. You don't need to. It's basically, to give you an example, your application doesn't need to know what the underlying service registry is. There's just a convention in terms of the host name that you use to call other applications. You no longer need to add explicitly a slew of dependencies into your application to inherit those capabilities, which means you don't need to manage the lifecycle of those dependencies. You don't need to update your applications to pick up newer versions or ensure that other microservices you're working with are sort of consistent with your application in terms of using the same sort of general version of those dependencies. So you don't have to synchronize on those tools. So what's nice, what Istio essentially enables is a really sort of orthogonal way of configuring all of these cloud native concerns, whether it's routing policies, security policies, resilience setting, how many times your application retries, or on what types of errors does it retry, timeouts for configuration, circuit breakers, outlier detection. All of these things can be configured without touching your applications. They are no longer concerns that your applications have to deal with. There's something that can be configured by a platform operator or by a development team, but orthogonally to your application. Your application does not need to be reconfigured, restarted, redeployed in order to modify those things. So this is the canonical picture, right, that is presented to explain the architecture of Istio. The fact that when you deploy applications or microservices to Istio, they get deployed, obviously, they're running inside pods, they're containers inside a pod, and what you see here is the sort of injection of an Envoy proxy, a sidecar, which is essentially what Istio programs in order to configure routing policy, security policy, resilience, retries, load balancing, and discovery, and more. So, um, so how do we explore this, right? And so the idea is to take a sample application written in Spring and to see if we could make it run efficiently on top of Istio. And for that, there is sort of a canonical sample application that's existed for a very, very long time by the name of Pet Clinic. Almost all Spring developers are familiar with Pet Clinic, and Pet Clinic itself has a long history, right? It's a long-lived sample application, was originally created to sort of show an example to developers of how you build an application that leverages the capabilities of the Spring framework. And as the capabilities of the Spring framework sort of grew in scope, so did Spring Pet Clinic sort of grow to take advantage and to demonstrate how you use those other projects. So it was a sample application focused on the domain of a pet clinic, the idea of of having pets and their owners, and they visit vets in order for them to receive care. And the application was manifested as a Spring application that used Spring MVC for the web sort of portion, the controllers. And as the landscape changed, as maybe it became more popular to build sort of client-side front ends that talk to a backend API, then different variants of this example application sort of grew. So Pet Clinic Angular is an example that used the Angular JS framework on the client side to talk to REST controllers on the backend. So there's lots of forks. Let's look at the Pet Clinic landing page. This is maybe I should first of all show you the main landing page called spring-petclinic.github.io, and you can read it and inform yourself about the whole history of the Pet Clinic sample application. And there's a nice big diagram. We'll get back to that later. Here's a screenshot of what the application looks like. You're looking at pet owners here and an invitation. This is open source to contribute. And if you look at the forks, there's lots and lots of forks that have been created over time. So we see, for example, a version of Pet Clinic that uses React on the front end, React.js, a very popular client-side library, and different forks. So here's Spring Pet Clinic data, JDBC showing you how to do data access with JDBC, and there's probably one using JPA and different client-side frameworks. And some that I want to call out is there's one called microservices. Microservices, this one, where that actually ended up taking apart the application and turn it into multiple separate microservices. And that's essentially what this diagram is all about. We'll get back to it in a minute. That shows how to sort of use Spring in the context of multiple running microservice applications. There's another one called Spring Pet Clinic Cloud that was derived from it that showed how to sort of extend the microservices version to run on specific cloud platforms, namely Cloud Foundry and Kubernetes. We'll get back to that momentarily as well. And some that maybe look at specific cloud provider like Azure. And here's the one on Istio, which is the one I contributed, which is going to be the focus of this talk. So that's a little bit about the various forks for Pet Clinic. So let's focus on microservices, right? It was introduced to demonstrate a cloud native version of the system, something modern, right? Where you didn't have a monolith, you had multiple separate running services. And here you see the application of those Spring Cloud libraries I was alluding to earlier. So if we go back to that diagram here, what you see is the application being broken up into 4 distinct microservices. There's this the component called the UI, which is sort of the back end for the front end. It's basically exposes the API endpoints and also bundles in process the capabilities of the Spring Cloud Gateway, which is interesting. And then sort of supporting that back end for the front end are 3 separate microservices, a customer service, which deals with everything related to customers. And by customers, that means pets and their owners, or owners and their pets, whichever way you want to look at it. The vet service and the visit service, which has information about the different visits that the pets might have undertaken at different veterinarians. And supporting all of this is Spring Boot, first of all. You see all these 4 applications are boot applications. And then there are different types of infrastructure servers. There's a Eureka service discovery for service registry type capabilities. So Kubernetes is not yet in the picture here. Maybe a Spring Cloud config server, which deals with configuring and reloading configuration from a remote source. And maybe monitoring servers that have to do with sort of showing you allowing you to monitor these applications. We also see that each of these backing services on the right has their own separate database, which is the right way, the way it ought to be. So that's a microservices version. We can explore that if we want to. Now enter another derivative of this project, another fork called the Pet Clinic Cloud version that showed how to run the same application on Kubernetes. And in this variant, in this fork, what you're starting to see is sort of the replacement of some of these infrastructure servers, for example, Eureka, with Kubernetes as sort of the foundation for doing service discovery. So some of the Spring Cloud libraries are beginning to vanish in this version, which is rather interesting. So the idea is, what if we took Pet Clinic Cloud as a starting point and took it even further and turned it into another project called Pet Clinic Istio, which ran on Kubernetes with Istio, and then to look at what it might take to sort of retrofit the application, and then to sort of retrospect and analyze, where that took us, what sort of benefits or maybe disadvantages, whatever, would derive from this activity. So we want to look at what it would take to run a set of microservices using Spring Boot on top of Istio. So here's what we're going to do. The work I've already done, the project already exists. And I'm going to walk you through end to end, deploying your own sort of Kubernetes cluster anywhere you like, whether it's on a cloud provider or even on your local machine. I'm going to use a local solution. And we're going to look at deploying the application on Istio, deploying those microservices to Istio, what you might have to retrofit in order to make that happen, how you might configure resilience, how you might configure ingress. And instead of using Spring Cloud Gateway, we're going to use Istio for ingress, right? Istio has an ingress controller that it provides with based on Envoy, for example. Instead of using resilience for J, we're going to use the resilience capabilities of Istio. So we're going to remove all of these Spring Cloud dependencies from our applications and instead use Istio's offerings and see where we end up. We're going to also configure authorization policies with Istio and look at observability, metrics collection, distributed traces, custom monitoring dashboards that Istio offers that could support our ability to maintain and observe our applications. All right, so this is the point at which we sort of step out of this presentation mode and start getting to work. And so we begin by inspecting the GitHub repository. The URL is spring-pet-clinic on GitHub /spring-pet-clinic Istio. And there you will find a very short README that will lead you to give you a very basic introduction. The fact that this fork derives from Spring Pet Clinic Cloud, which in turn derives from Spring Pet Clinic microservices, and that instructions are published on a portal, which you see here. And we're going to use those instructions as our basic walkthrough. Okay, so maybe I'll make the font size a little bit bigger. Here's a kind of an introduction of what Spring Pet Clinic Istio is all about. And we begin with a setup step. And so let's see what are options here. We need a Kubernetes cluster. We can either use a local or a remote setup. You can essentially bring your own Kubernetes cluster if you wish. And I'm going to use a local setup. I'm going to copy this little command, which basically uses K3D to create a local cluster on my machine. So here you see me on at a command prompt, and I'm just going to paste this command, and I'm going to create myself a Kubernetes cluster on my local machine. So that would be step one. And what we see here is K3D getting to work. Now, this doesn't just create a local cluster, it also creates a local registry where I can push my images to, which then would be available to my cluster. I also remove the default traffic-based load balancer because we're going to be used, sorry, not load balancer, yeah, because we're going to use in its place Istio as our load balancer. All right, so our Kubernetes cluster is up and running. I could type, for example, kubectl get namespaces, and there are my namespaces, kconfig get context. I have a Kubernetes context. All right, so given that we have Kubernetes installed, there is a certain attention we have to give to environment variables. And what you will find when you check out and clone this repository, which I have done here, I've already cloned this repository, is you'll find a file called envrc-template. And that's basically a little script that configures environment variables. So you decide whether you want a local setup or not. I'm using a local setup. So, and I'm also using dir-env, which basically has a convention of setting your environment variables for you automatically based on a script by the name of .envrc. Here I'm defining that I'm using a local setup, and my load balancer IP is just going to be localhost, and the name or the URL to my registry for pushing Docker images and for pulling them from Kubernetes is set here in advance. So if I echo these environment variables like the pull image registry, you see that's already set for me. So I've got my environment variables sort of set up. All you have to do is essentially copy this template and configure those variables to whatever you choose. So if you have, for example, a remote cluster and a remote Docker registry, if you're using, for example, Docker Hub, you would set your image registry URL to Docker Hub instead. All right, so next step is to install Istio. So that means you'll have to download Istio, which will give you the URL here to downloading a copy of Istio. So that's pretty straightforward. You basically run this curl command here, which will download a local distribution. The latest version at the time of recording here is 120.3. And then you'll see that there are a variety of samples here under the samples folder after you, and the Istio CLI needs to be added to your path. And that's what step 3 here does. It adds the Istio CUDL client to your path on Linux or Mac OS. And I've done it already. So if I type which Istio CUDL, for example, or Istio CUDL version, you'll see that 120.3 is the version of Istio that I've downloaded. Now it's not installed on my Kubernetes cluster yet. That's why it says no ready Istio pods in Istio system, the namespace to which Istio typically installs. You'll see that my distribution of Istio, let's see, I'm going to create a symlink to my Istio distribution so I can just reference it here, and you'll see the Istio bin folder contains the Istio CLI or what have you. All right, so now I need to run the Istio CUDL install command to install Istio. And I supply a manifest, and just want to walk you through real quick what exactly that manifest configures. It essentially configures 3 things. One is it turns on access logging to standard output for the sidecars, so we can tail the logs of the sidecar container and see what Envoy is doing. I also increase the trace sampling rate to 100%. From the default profile, I think it might be 1 or 10%, I forget. And that just makes it easy for us to test. And then the other thing I do is I also turn on the what's called the MySQL filter, which sort of enables proxying not just my microservices, but also my MySQL databases, which allows me to sort of take advantage of things such as authorization policy. All right, so that's what I'm configuring here. So we're going to run this command, istio-cudl install, and specify the manifest. And that will install Istio on top of my Kubernetes cluster. All right, that'll take just a second. And then we can start to look ahead. We can run optionally after the installation finishes this verify install command to verify that all the CRDs have been sort of installed to my Kubernetes cluster, and all the other components that make up Istio are indeed there and functioning and up and running. And then the other sort of operation we typically perform is defining or turning on sidecar injection. So we label the namespace, and here I'm going to be deploying my workloads to the default namespace. So I'm labeling that namespace with Istio injection equals enabled. And I could do that in parallel while Istio is still installing. So I've labeled, here we can look at that. I've labeled the default namespace with Istio injection equals enabled. And Istio just finished installing, and I could type istio-cudl verify install, and you can see a bunch of green check marks saying Istio is installed. So that's all good. We can even look in the Istio system namespace here and notice that Istio-D and the Istio ingress gateway are up and running. So we're good with this step. Let's move on to the more interesting part, which is to deploy Pet Clinic. All right, so Pet Clinic, these microservices use MySQL. That sort of was inherited from the previous version of the Pet Clinic that I started from. Each of these three microservices, the customer service, here maybe I can flash again where is it? Yeah, this. If we look at this diagram here, you can see a customer service, a vet service, and a visit service each have their own database, and so we need to deploy those MySQL databases, three of them. We're going to use Helm to do that, and so you need to make sure you have Helm installed and with the Bitnami repository in your list of repositories, and we can then run Helm repo update, and that'll update our repositories. And then we're ready to essentially deploy MySQL. This is a vanilla MySQL, three instances, one for the vet service, one for the visit service, one for the customer service. So Helm install, we name each of our databases, vetsdb MySQL. That's essentially the name of the cluster IP service we're going to end up with. And here's the Helm chart. And we're going to use a database named service instance DB, a very generic name. The output tells us that to be patient, that MySQL is coming up, and that once it's up, we can where we can find the password, the root password for the database, and how to test connectivity. We'll be doing that momentarily. So let's go ahead and deploy the visits and customer services as well. And as soon as that finishes, what I'm going to do is look at the pods, and here you're seeing the pods initializing and sort of coming up, are in the process of coming up. And notice that they are, we've got two containers there. They're going to be fronted by a sidecar as well, an Envoy sidecar. So that takes 1 or 2 minutes or so. And while this is happening, we can start turning our attention to the actual Spring Boot projects. So if you look at the repository, I've got it pulled up here in my IDE. You could see 4 different modules. There's a customer service, the front-end service, the vets, and the visit services. They're all Spring Boot applications. And if you start to sort of poke at the code, by the way, you should know that there are 2 branches. There's one, there's the original Java, and then I also ported the code to Kotlin. If you're interested to see, there's also a Kotlin version, a monolith version of Pet Clinic that uses Kotlin, but this is the microservices version. But here's a typical, Spring Boot application with its main method. There's the vet repository using Spring Data JPA. Here's the REST controller with the request mapping to the /vets endpoint. And here's the and just a single endpoint that returns a list of vets, which uses the repository that's auto-wired into this controller to find all the vets. So that's more or less how things work with Spring. That's pretty sort of standard and straightforward. Anyone who's built a Spring application knows how this works. And here's our JPA entity that maps the vet object to the vets table with a list of columns and some additional getter methods. And there's a list of specialties that each of the vets have. And there's some configuration here that preloads the database, defines the database schema, as well as preloads data into the database. I think, yeah, it's just the data, not the schema. And then the application configuration. We'll talk about the application configuration in a moment, but here you can see the name of the application is vet service, and the initialization of MySQL and the JPA configuration, and there's some more information here about the way configuration of shutdown to be graceful, or management endpoints, and so on, liveness and readiness, and support for Kubernetes. We'll talk about that momentarily. So this is the vets service. There's also in a similar fashion, the customer service, and again, you can look at the code and look at the application and the controller and the controller endpoints and the repositories and the entities. It's all in there. The front end is a little more interesting in that, well, it's this project. First of all, I should take a step back and point out that it's a very conventional, maybe I should say stereotypical way in which this repository is set up. All 4 modules, all of the code is in a single repository. So you may say this is a little bit different from, say, 12-factor applications that ask for a separate repository. It really depends on whether you have multiple teams maintaining the code or not. So you have this project is configured with Maven. It's built with Maven, and here you see the POM file for the Pet Clinic front end. You can see the dependencies also for this application. So this is the front end that sort of serves up a lot of the Angular stuff, and so it's got a lot of web jars in here. But besides that, it's got a lot of the Spring framework, Spring Boot. How's the Kotlin dependencies? Somewhere is the Spring Boot web. Um, hmm. Let's go back to my dependencies section, see if we can make sense out of this. So there, Spring Boot starter Webflux. So this uses Webflux. There are two options for web with Spring. There's the sort of the reactive version and the non-reactive. The other modules, if we take a peek, say at the visit service, for example, in its POM file, and if we look at its dependencies, we'll see that this uses the Spring Boot Starter Web. That's not the non-reactive version, and the data JPA and the MySQL JDBC driver. Whereas here we're using Webflux. We've got the Kotlin dependencies, and then some of the front end stuff. And on the back end, you see the Spring Boot actuator, Prometheus for exposing metrics. And we'll talk about distributed tracing momentarily as well. So that's just kind of a quick and dirty overview of the code that you sort of have to orient yourself with. And with Maven, you build the code with a Maven package command. So we can type Maven clean package. I've already done that. That takes like a minute or so. Where most of the time is spent actually is building the images. That takes about 5 minutes. So you build the code, it runs all the tests, it compiles the code, it packages the code into jar files, for each of the modules. And then you build these Docker images and you push those images. Let's look at the push images script. It just does a Docker push to your registry endpoint. So let's go ahead and push these images, which I've already built. So that'll save us a bunch of time. And now in this case, it's a local Docker registry. I have all my images. I can look at my local images. Maybe I can do a grep on Pet Clinic here to see that my 4 images, Pet Clinic front end, the vet service, visit customer service, have all been sort of built. So I've got my images, they're pushed to my registry. And so now I'm ready to deploy. And for that, I need deployment manifests. Each of these 4 applications or deployments to my Kubernetes cluster. And we could look at 1 or 2 of these. They're all fairly similar, self-similar. There's a service account for each application. There's a definition of a cluster IP service listening on port 8080. The selector is the visits service. The deployment for the visits service is called visits v1. And it has a label, visits service, and version v1. This is kind of a convention with Istio. App and version labels are typically what you define for each of your applications, the number of replicas, and then a template for the pod spec. You can see here the service account name is mentioned. So the pods have an associated service account, in this case, visit service, and the reference to the image we just built, the latest version of the image for the visit service image, and the port it listens on, and the readiness probe and liveness probe, and all of that information. And environment variables, how to connect to the database. So the Spring data source username and the data source password comes from a secret that was deposited when we installed MySQL. So that's a walkthrough of the deployment manifest for one of these 4 services. And if you pay close attention to the reference to the image, you notice here a reference to an environment variable, the image registry that we're using. And so in order to dereference that, I basically cat all these YAML files and pass them through an environment substitution command, which will sort of substitute the environment variable for the actual URL of that registry, and then kubectl apply all of those manifest files to my Kubernetes cluster. So it's high time we do that. And then if we look at our pods, what we see is our databases are running now, and our applications, the microservices themselves, are in the process of initializing, and they all have 2 containers. They have an Envoy sidecar. So that's great. So if we actually looked or tail the logs for any one of these services, you can actually see the Spring applications coming up. There you see the Spring Boot banner. We're using the latest current version of Spring Boot with Java 21, and it's initializing and probably configuring our database as we speak, and setting up a connection pool and whatever else the Spring application is doing, initializing JPA, Entity Manager Factory, and you may be quite familiar with that. All right, so our applications are coming up. You can see that here. Great, everything's up and running. So we should be able to visit the application. Well, before we get there, let's do a couple of due diligence tasks. The first one is just to make sure our connectivity to the database is configured correctly. So let's go ahead and grab the password for one of these databases. I'm going to pick on the vets database. And what I want to do is run a kind of another pod, a MySQL client, one that has MySQL or based on an image that has MySQL installed on it. And that will, from that pod, we'll be able to run a MySQL command and use that password to talk to our database. So we wait just a few seconds here for this container image to get downloaded and for the pod to initialize and to become ready. And as soon as it becomes ready, we'll be able to run the MySQL command to connect to the database. Let's inspect what that command looks like. We're going to talk to the vetsdb MySQL running the service running in the default namespace. We pass in the username and the password through the environment variable that you can see is sort of being threaded through to our pod from the environment variable that we just created by reading our secret. Okay, and so I see an error here. Timed out waiting for condition. That's not good. So let's try that again. It already exists. Okay, great. Okay. Okay, so here we are. The command actually succeeded after, for some reason, it timed out the first time. I just reran the command, and now I've got my prompt inside my MySQL client, and I'm ready to run this MySQL command, which will give me a MySQL prompt. Yeah, okay. How do I do a clear? Let's see. -C? Okay, I don't know. It's not working. Doesn't matter. All right, so next step is essentially to connect to the specific database that we want to talk to and to show tables. And here you see a vets and specialties table and some kind of a vets underscore specialties table as well. And you can say select star, for example, from vets or vet specialties, because that's a many-to-many relationship. And what you're seeing here is a list of vets has already been populated. So our application is talking to our database, and this has just sort of verified that that everything is connected properly and functioning as I expect. So we have an application, but we cannot actually visit our application on the web page until we configure ingress. So let's turn our attention to talking about ingress. The original application configured ingress through the Spring Cloud Gateway project. And you could see here the Spring Pet Clinic Cloud. So this is the Spring Cloud Gateway project sort of documentation page, your getting started page. Here, of course, we're going to use Envoy or Istio's ingress gateway component for for configuring the ingress. And if you look in our Istio system namespace here, let me just yeah, let's do that. You could see the ingress gateway is up and running. It's just not configured. So the task is to configure this ingress gateway to allow ingress on a particular protocol or port. We're just going to use plain HTTP traffic on port 80. And this is the stanza that configures ingress in Istio. It's a standard gateway resource. And here you see port 8080 is exposed for all hosts, and we can just essentially apply this bit of YAML, which you'll find in the repository under manifests ingress. There, it's all there. So now we have a gateway configured. And once the gateway is configured, if you try to curl, make a request to the gateway IP address, you'll get a 404, and that's because we haven't yet configured routing. Right, so that's the next step, configuring routing. So this is interesting because the routing rules, these are the original routing rules from the Spring Cloud Gateway version of the project that defined routes in the sort of vocabulary that Spring Cloud Gateway exposes. And so the task of making this work with Istio was to essentially translate, throw away this config map. This is an application YAML file that configures in Spring, the Spring Cloud Gateways and the endpoints to the visit service, the vet service, and the customer service with an Istio equivalent. And here you see the Istio equivalent. You have, I called it, it's a virtual service called Pet Clinic Routes, which binds to the main gateway that I just created. and sort of exposes specific endpoints on different services. On the customer service, the /API/customer should route requests to the customer service, and likewise API/visit, API/vet should route requests to the visits and vets service correspondingly. Now, in the original Spring Cloud version of this Pet Clinic sample, the Spring Cloud Gateway was not a separate component. It was actually bundled in process with the Pet Clinic front end. This is not the case with Istio. So again, if we look at this diagram, this box that I'm highlighting here, UI plus API gateway, in the Istio version variant, the ingress gateway is separate, and the Pet Clinic front end is just another backend service behind that gateway. So we have to expose that too. And so that's what I do here is I say any sort of request to /API/gateway should get sent to the Pet Clinic front end service. So let's go ahead and apply this bit of YAML to our Kubernetes cluster. And now we have a virtual service, which will take care of exposing all the routes that the front end, the UI of the application is going to need to call back into in order to function. So now we should be able to finally go to our ingress gateway IP, and our Spring Pet Clinic application is now deployed. We can look at different endpoints. Here's the veterinarians. Here's the list of owners. Well, what's going on? There it is. Took a second. And we can drill down, or we could use a search filter. This is a pure client-side feature. Not too interesting. Here's the owner, George Franklin, and his information, and his pet Leo, which happens to be a cat and has not had any visits to the vet yet. We can add a visit. We can create a new owner, for example. We can come over here and register. Maybe I'll register myself as an owner here, Eitan at 123 Sun Street in Austin, and my fictitious phone number. So there's a new owner. We can maybe give this owner a pet. Maybe I'll give him a birthday. Let's see, maybe January 1st or 10th, 2020. And maybe it's a cat. So I've given Eitan. So it seems the application is functioning correctly. We've just created an owner, given him a pet, and maybe we can even add a visit, maybe a first checkup on today, on February 20th, 2024. All right, so our application is now deployed, and we visited the app. It seems to be functioning. So let's now continue and begin to acquaint ourselves with the API endpoints that are exposed by this application. Now, there's a couple of ways we can call these API endpoints. Since these are all exposed through ingress, we can just curl the ingress gateway IP, which in my case is just localhost, and that works just fine. But we can also curl those from inside the Kubernetes cluster. And for that, we're going to use the rather well-known sleep client from the Istio distribution. Now, the sleep client, all it is a pod that is based on has a container that is based on an image that runs curl. And so we can run curl commands from within the cluster to any of the services we have running. So as soon as this sleep client is up and running, then we can maybe run a token call like this. We can kubectl exec from the sleep client and run the command curl to the vet service and call the vet endpoint and maybe pipe that through JQ, and then we could actually see the JSON being returned by the application. So it's just that simple. Now, if we were to make the same call through the ingress gateway, we would use just a direct curl command. We wouldn't need a kubectl exec at all. And then the endpoint would be /API/vet/vets, and we type that through JQ, and we get the same information. So this is a list of veterinarians, their names, their IDs, their specialties, and so on. And then we can also familiarize ourselves with some other endpoints available on some of the other services, like the customer service. If you want to look at the owners, here's a list of owners in JSON. There's Eitan, the owner we just added a moment ago. Now, you can sort of begin to understand that the web-based front end, I think this is based on Angular, is actually making calls to these endpoints, grabbing the JSON, and the data is then being rendered as HTML in the front end. That's how that works. If we want to look at a particular pet, I'm picking on pet with ID 1. Here you see the pet Leo that belongs to the owner, George Franklin. So it's just that simple to sort of make calls to these endpoints. We can even give maybe George Franklin a new pet. We could do an HTTP post JSON. We can add some JSON. Sir Hiss is going to be a snake that belongs to this guy named George Franklin. So here we get back an HTTP 201 created. That means we've created a record, and we can verify that, right? We can come over here, look at George Franklin again, and we can see Sir Hiss is a new pet alongside Leo, which was the original pet that George Franklin had. So these endpoints seem to be functioning just fine. Just for the sake of completeness, let's go ahead and look at the visit service so we can build some familiarity with the visit service. So here we can look for all the visits that pet ID number 8 has had by making a call to this particular endpoint. I think in my shell I need to escape this little question mark there. So here you see that this particular pet has had 2 visits on particular dates on March the 4th and of 2011 and June the 4th of 2009. And then finally, this is an interesting one. We can make a call to the pet clinic front end, okay? And this is what's interesting about this call. Maybe we look at the code for a moment. Let's look at the pet clinic controller. And we're making calls to this very particular endpoint here that you see on line 112, get owner details. We pass it an owner ID. And this is a bit of reactive code that makes a call to the customer service to get the information about the owner and their pets. And then for each pet, then we turn around in a reactive fashion and make a call to the visit service. Now it's a single call. We pass in all the pet IDs of that particular owner in a single request, and we get back all the visits for all the pets, and we sort of aggregate the data, add visits to owners, basically adds a visits stanza to each of the pets that are returned. So this is a great example of an aggregation. You're calling a microservice, which is calling 2 other microservices on the back end in turn to get kind of an aggregate set of data. And here you see the response. So we're making a call for owner number 6, that's Gene Coleman, and you can see that he has 2 pets, Max and Samantha. And for Max, we see he has had 2 visits, and Samantha has also had 2 visits, and this call succeeds. So that's essentially an overview of the application at the sort of what I like to call the subcutaneous level, which is a term that Martin Fowler sort of coined. All right, now this is where things begin to get interesting, because now we start looking at capabilities that different Spring Cloud libraries have sort of brought to bear. So the original version of this app used Resilience for J, which is a popular library that people use for resilience, for configuring timeouts and circuit breakers and so on, and fallbacks. That code was essentially ripped out of the Istio version of the application, because Istio can configure timeouts and resilience and circuit breakers. And so all there was in the original application was a configuration of 4-second timeout on calls to the visit service. So when the pet clinic front end made call to the visit service, if the visit service took longer than 4 seconds, it would fail fast and fall back to returning no visits. And if you look at the version of the code now, all we're doing, there's this bit of code used to have resilience for J annotations and configuration in here. And instead, what you have is an on-error resume. If you get an error, and that error happens to be a gateway timeout, then we're going to log that information and return an empty set of visits for pets. That's going to be our sort of poor man's fallback to an eventuality where the service that's upstream from us is timing out, is taking too long, right? So notice that this code is written without resorting to a Spring Cloud library whatsoever. We just look for a gateway timeout, and we configure the timeout through Istio. We tell Istio, here's a virtual service for the visit service. The host name is visitservice.default.service.cluster.local, and the timeout is 4 seconds. So we can apply this YAML, and now we have our visits virtual service with the timeout. Okay, get vs visits -o YAML. You can see a timeout of 4 seconds. So we've applied a timeout. Now these services are much faster than 4 seconds, so they're not going to trigger a timeout, right? If I make a call here, we're calling the visit service and we're not triggering a timeout. And so in order to trigger a timeout, what we can do is I've instrumented the application with an environment variable, the visits application, called delay millis. So if you add a certain delay through an environment variable, the application will just sleep and will take longer. So let's do that. Let's go ahead and edit the deployment and look for that environment variable. Here you can see the container environment variables, and we'll set the number of milliseconds to 5,000, 5 seconds, so that we can trigger this timeout. Now, when we modify the deployment, what you see Kubernetes doing is it's rolling out and restarting the vets. Let's see. I want to delete this guy. Let's see. Okay, delete. I don't know why. Yeah, why this happens, but we should be seeing the visits v1. Yes, visits v1 is coming up. You see it's been up for 25 seconds, but it's not ready yet. And you see the old visits v1's been up for 17 minutes. So as soon as the new version of the application is available, we can then submit this request again. Let's see if I can find in my history. Yeah, the call to the owner's endpoint. Maybe before we do that, actually, let's make a call to the visits endpoint directly. I'm going to use this version. So here I'm making a call to the visit service for pet ID number 8. I want to know their visits. And notice this is taking several seconds because of the timeout. And after 4 seconds, what we get is a 504 gateway timeout. So the timeout policy is working. And the question is a client of this particular visit service, how are they going to handle this timeout? Are they going to fail too? Or are they going to use that fallback? So if we look, for example, at this call we made a moment ago to the pet clinic front end to look for owner number 6 with his pets and their visits, you'll see again a 4-second lag and the timeout. But here what you see in the result is an HTTP 200, but the visits are just an empty list because that's our fallback. So the resilience capability that was there previously has been sort of ported to Istio, and there's no more use of a Spring Cloud library in order to support this capability. Now, there are plenty other resilience features in Istio, such as outlier detection, which I'm not showing here, which has the ability of sort of quarantining a workload that is misbehaving for a while and then sort of reintroducing them after they become healthy. So there's other resilience features we can look at. And if we sort of tail the logs of our pet clinic front end, you will see from our code we were logging that the response for visits was returned to 504, and we indeed see that was triggered here as well. Okay, before we proceed to our next sort of demo or scenario, I'm going to go ahead and quickly clean up what I did earlier and remove the delay that I had artificially introduced to the visit service. And that should be percolating while we sort of turn our attention to the next topic, which is security. Now, again, there are many security capabilities built into Istio. Here I focus on maybe a simple use case, but a very important one, which has been sort of plagued the enterprise for many, many years in the past. This sort of problem called integration at the database level. I think I summarize it well here. That historically, what a lot of teams would do is they needed data from another team, and sometimes they would go around the team's APIs and just sort of make calls directly to the database. Now that's really problematic in that that basically couples multiple applications to a particular schema. That's an internal concern of a particular service. It should be none of the business of any other client that needs information. They should be using an API. And so what we want to do here in this scenario is enforce that all requests from clients go through the API and not around the API and directly to the database. And so this is what we want to try to enforce. So here's an Istio authorization policy. In fact, there are 3 almost identical authorization policies for each of our 3 databases that basically, through a Kubernetes selector, target a specific database, the vets DB, the customers DB, and the visits DB. And the rule is very simple. It basically says, okay, allow requests to the database. Notice that there's an Envoy proxy in front of the database that's given this configuration essentially, or a translation of this configuration, and it acts as a guardian that says, okay, who are you? Oh, you're the vets service? Okay, I'll let you into the vets database. That's basically it on port 3306, right? And a similar sort of stanza for the customers database. Only the customer service can talk to the customer database, and only the visits service can talk to the visits database. And by applying these policies, we can sort of enforce that no one other than the corresponding service that is associated with that database is allowed to talk to that database. So we apply this authorization policies, and we see them here. And we can essentially test that the policy is really enforced. And we could do that in a way very similar to what we did a moment ago. That is, we can pick on any one of these databases. Let's pick on the vets DB. We can grab the password. Oops, that's the wrong command for the shell that I'm using. So let's use this one. Okay, so my SQL root password has been sort of grabbed from the secret and decoded. And then again, we'll run this is a standalone, a separate pod, okay, that's that has the MySQL client installed. And when we try to connect to our database, because we're not the vet service, we're not allowed to connect. Notice here. And if we were to tail the logs of the Envoy in question, let's see if we can do that actually. That would be pretty cool. We should be able to see some kind of RBAC access denied. So let's do that. Let's say k logs follow -c Istio proxy. I think the container is Istio proxy. And here what you should see is some kind of message about access denied. Let's see. Connection refused. See there? Yeah. Is that? No, that's for a readiness endpoint. That's interesting. Okay. It may be higher up. I'm not sure. Okay. I'm not very good at sifting through a ton of text, but we'll leave it at that. So we basically have an authorization policy that prevents anyone else from being able to accessing our database. And that's terrific. Now, the way this works, and this maybe, if you're not too familiar with Istio, begs elaboration, is this is one of the features that Istio makes, unlocks for your microservices or your cloud native application. The fact that Istio will assign a cryptographic identity to each of your workloads based on the namespace and service account, and this framework called SPIFFE, Secure Production Identity Framework for everyone. You can read all about it here at spiffe.io, which essentially allows me to identify who is calling who inside my mesh, because every microservice has an identity, which can be referenced here through a URI or a principal. Here you could see the name of the actual URI for the customer service identity based on the customer service account. All right, so that's a little bit about security. There's much more about security. You can configure different types of authorization policies to different endpoints based on even JOT tokens for end users or workload identity, as we've just sort of illustrated here. So let's move on to the observability capabilities of an Istio-based system. And we'll begin, observability is typically a three-legged stool, right? One of those legs is distributed tracing, the other one is logs, and metrics is the third one. And so we'll begin with distributed tracing. And it's important to maybe begin this conversation and to mention that in Istio, Envoy will automatically inject distributed trace headers, but it cannot propagate them. And that's essentially what this page talks about. It talks about the trace context propagation. And so you, as a developer, have the responsibility of ensuring that a call that you receive, when you turn around and make a call to an upstream service, you've got to propagate those request headers, sorry. And they're typically called B3 headers. And here you see the exact names of the headers that you must propagate. And there are different headers that you have to add to the mix depending on what type of monitoring solution you're using. So if you're using Datadogs, there may be some specific trace IDs you need to propagate. And we can look at how this was done for our microservices in a Spring Boot application. This is one of the things I love about Spring Boot is the fact that you can here through configuration. This is management endpoints, I think. Yeah, the management dot tracing dot baggage dot remote fields. All I had to do is specify the list of fields or trace headers that I wanted to be able to propagate. And micrometer tracing is the library that does the rest, does all the work on my behalf. So you can see here in my list of dependencies, let me see. Somewhere on this list, you will find micrometer tracing right there. And there are multiple implementations. There's an open telemetry one, there's the Zipkin one, and so you can pick whichever one that suits you best. And you've got the trace header propagation sort of implemented, which is superior, in my opinion, to say, if you look at the source code of the book info application, which comes with Istio, what you'll discover is that that work is done by hand inside those sample applications because they don't have sort of a library that could do this in a sort of a true cross-cutting fashion that you can with some of these Spring dependencies. So that's the first thing I wanted to point out is the sort of what I had to do in my application to ensure the propagation of these trace headers in order to be able to view distributed traces. Now, so we've got the right dependency, we've got the right configuration, and I've shown you both of those. And I've already configured my application or Istio with 100% trace sampling. Now, this is not realistic, but here I'm doing this for learning purposes, so it's very, very useful in this case. And we begin by deploying a distributed tracing solution. There are a number of them out there available, of course, many for you to choose from. Istio gives you a Zipkin and a Jaeger sort of deployment manifest that you could deploy to the very Kubernetes cluster that you've got your applications deployed on. So let's go ahead and apply the Jaeger solution, and that will result in the creation of a Jaeger deployment in the Istio system namespace that's in the process of coming up. So I'm right now pulling up Jaeger. Or pulling up, provisioning Jaeger. And what we want to do is essentially send at least one request through our system. And this is a good one, a good candidate one, because it creates this nice call graph. You're calling through the ingress gateway to the Pet Clinic front-end service. It turns around and calls the upstream services, customers, and visits. A very nice example. I want to make sure my Jaeger is already running so we can collect a trace sample. And when I make this call and we get a response, this took a while. This is typical of Spring. Typically, after the first call, you see the warm up and the caching has already taken place, and the requests now are taking much less time. And if we look at the Jaeger dashboard, which we can bring up with the istio dashboard command and look for traces, we can maybe look at some of these representative traces. And here you see a nice visualization of the call graph, essentially, from the ingress gateway to the front-end service, which then turns around and calls the customers and visit service. You can see exactly how much time is spent inside each of these microservices. So this is great for, first of all, understanding the call graph, but also understanding latency, where time is spent, and how that time is sort of divided between all of the different services. So I won't go much further with distributed tracing. Let's go ahead and close this dashboard and move on to the next step, which is the collection of metrics, which is, I think, a terrific example because Spring Boot provides metrics collection capabilities through micrometer dependency. You'll see is in our POM file. We can come back over here and look at one of those POM files, and we should be able to see micrometer registry Prometheus. We're going to be writing or collecting those metrics in the Prometheus database. So we need to deploy Prometheus, and that's somewhere further down. Why don't I do that right now? Might as well. It's again another one of those add-ons. We'll deploy Prometheus. Now, one thing that's interesting that I discovered about, I'm using the latest version of Spring Boot, which makes use of a version of, sorry, a feature of Prometheus, which is available in only version 2.43 and later. And the latest version of Istio is still using version 2.41. And so I'm actually patching Prometheus with this little patch file, which is going to use the latest version of Prometheus image, which will essentially allow um, Spring Boot, it uses this feature called exemplars, which is not supported in the currently deployed version of Prometheus. So there, I just patched it. All right, so while Prometheus is coming up, let's talk about scraping, right? With Prometheus, it's a sort of a pull-based system where you're exposing a scrape endpoint. And in my POM file, I've got two important dependencies, actuator and Prometheus, and the configuration of the exposure of those Prometheus metrics through an endpoint. I guess we can look at that as well. That would be in application.yaml. Yeah, so web exposure include asterisks and metrics export enabled. So we're exporting Prometheus metrics, and we can look at those endpoints. We can make a call to the this one. This is the Prometheus scrape endpoint exposed by the Spring Boot application. So here we see a whole bunch of JVM metrics, right? And there's a whole bunch of them in Prometheus format, and connection pool metrics and other metrics. There may be business metrics also included in the mix. So those are the metrics collected by the Spring Boot application on our behalf. Now, Envoy also collects metrics, and it has its own separate scrape endpoint on port 15090. And you can see that here, and you can see Envoy server metrics, Envoy listener metrics. There's Istio metrics here, and latencies and so on. So lots of information. We need both, and so Istio provides a mechanism through the Istio agent, which hold on just a second. Okay, pardon the interruption. All right, so here what we see is Istio providing the capability of merging both scrape endpoints into a single endpoint. And so when I make a call to port 15020/stat/Prometheus, what I end up getting are the metrics from both the Spring application and the Envoy sidecar sort of aggregated together as a single scrape endpoint to configure Prometheus to pick up all of these metrics for me in one place. And all I've had to do in order to enable that is essentially add a little bit in my deployment manifest. Let's look at the let's look at the deployment manifest for, say, the customer service, and they're all sort of instrumented the same way. And what you see is the pod spec has an annotation section, this is Prometheus annotations, that specify exactly the endpoint where the application is exposing its metrics on and the port and whether to scrape that endpoint as well. So that tells Istio, hey, go ahead and call that and call the Envoy endpoint, aggregate them into a single sort of list of metrics that Prometheus will then scrape. So that makes it rather convenient. We have a single endpoint that we can configure Prometheus to scrape periodically to get at all these metrics. And in order to generate metrics, we probably need to send a load against our application. So let's come over here, and you can look at this list of URLs. It's just a random list of API endpoints that our application supports, and we can send a bunch of requests to these endpoints, which will generate metrics like a request per second, or the success or failure of requests, the latencies that these requests took, and whatever JVM metrics are also being collected by the application itself. So that's great. We're sending a load against our application. We can spin up the Prometheus dashboard. What was that? I'm not sure. Oh, that's the wrong. Apologies for that. I've already applied this. Actually, that's not good because I should have patched. Let me go ahead and patch this again. Okay. All right, so what I wanted to do is, this is the command I was looking for. I wanted to spin up the Prometheus dashboard. So let's see. This is the Prometheus dashboard. It looks pretty raw. It's basically a console for running PromQL queries. And so I give you a couple of sample PromQL queries that you can run. Here's the first one that looks at Istio request total. Istio request total is one of the metrics sort of that Istio collects, and you see here the count is 81. So 81 requests have been made from the pet clinic front end to the customer service as reported by the source, by the pet clinic front end. If I run this again, maybe a little bit later, you see that the count is increased to 97. So the metrics are being sort of ingested into our time series database. Another common sort of function that you can run against Prometheus is the rate. So the Istio request total is essentially a counter. It's monotonically increasing. And over time, as time goes by and those requests are being collected, you can look at the rate of requests coming in by using a Prometheus query language function called rate. So you can look at the rate over a specific time window, and maybe I can make my time window a little bit. It looks like this is still ramping up, so we're not, but the rate of request is going to arrive at a kind of a steady state at some particular point. Okay, so it looks like, let me look for another metric, one that I know that my application is actually publishing. This is a custom business metric. This is the number of, number of calls to the find pet method on the REST controller. So when we're looking up a pet, we're sort of counting that. Let me show you how that works. So this is, I think there's a pet controller, not pet clinic application, pet controller. Here we go. And if you look at that pet controller, where is that pet controller? The pets controller. There it is. You see this annotation here, at timed petclinic.pet. This essentially exposes the capture of timing metrics and also counters that for each of these controller endpoints. So find pet is one of them. Where's find pet? There it is. And so the number of times that this was called is actually captured as a metrics, and you can see that here. Okay, so that's just a proof that we're actually collecting metrics both from the Envoy sidecar and from the application proper. There are also JVM metrics, right? There's JVM buffer count, whatever, and other Spring metrics that are being collected. For example, the count of invocations against a particular repository. Here you see that sort of count seems to be growing, and we can again look at rates from these raw metrics. So that's the Prometheus dashboard. Now, what we want, of course, is something that less raw. So a pre-built dashboard that shows us all of the basic metrics we want to basically that will allow us to monitor our application. Red metrics, right? Requests, durations, all of the main and important things, the golden signals, as they call them, that our application can that we want to know about our application. So for that, we will deploy the Grafana. What is this? Not sure what that was about. For that, we will deploy the Grafana solution. And along with Grafana, we deploy these Istio dashboards, which are pre-created for me. Now, one of the things I want to do, yeah, that's fine, is wait for that Grafana deployment to be ready. So let's look in Istio system. We see Grafana container is still being created. And once it's ready, we can open its dashboard and look at dashboards. And they look something like this, right? So the different service dashboards for each of our services. We can look at the request volume or the success rate, which is 100%, or the latencies at different distributions, P99, P90, and so on. Let's see, is Grafana ready? Yeah, not quite. Almost. Let's do a -W on that. Here we go. Okay, now it's ready. All right, so this is the Grafana front end. We could look at the dashboards, and what you'll see is that there's an Istio folder with a variety of Istio dashboards. And the Istio service dashboard is I think, what I had in my screenshot here. You could see latencies, success rates, request volumes. You could see requests for different services. You can pick which service, for example. We can pick on the visits service, for example. And we can look at what clients are calling it. So this is a graph that shows, for example, the distribution of requests that come from the ingress gateway versus maybe the pet clinic front end. You can look at your clients. You can look at there's other information besides the service workloads, workload specific. And if you want to, if you have maybe two versions of the application deployed, you can focus on a particular one, I think, or this is a breakdown of the service by workloads. But in this case, we have only one, so that doesn't really tell us much. We can also look at the Istio workload dashboard and see sort of similar information. This is, let's pick the vets service. So you can see that, again, the volume of requests to that particular workload or what have you. So that's nice. Notice that with Istio, the advantage is these dashboards are built for you because they're based on standard metrics which Envoy collects. So you don't need to get in, you're no longer in the business of building your own sort of custom dashboards unless there's specific application metrics you want to see. And that leads me to my next point, is it turns out that I've actually inherited a custom Grafana dashboard. You can see it in the Git repo. It's a JSON file. Let's see if I can find it, by the name of Grafana pet clinic dashboard.json. And so this is something somebody put some time and effort into, and we can import this this JSON file. Let's see if I could find it. Here it is. And we could tie it to our Prometheus data source and import it. And here you can see what's interesting is the two top panels are technically made redundant by Istio, with the fact that Istio is already collecting request activity, and you can see it in the aggregate as well, not just for a particular service. So if we come back here to the Istio mesh dashboard, you can see some aggregate data. And I'm not sure what accounts for the discrepancy. I think this says 7.3, and I think the number was slightly higher in the other dashboard, the Spring Pet Clinic metrics. By the way, there are also standard Spring Boot dashboards from the Grafana dashboard registry that you can pick up here. But the point is, you don't really need these panels anymore. They're kind of redundant, but maybe this is a nice aggregate dashboard. And here what you see is maybe some custom application metrics. Owners created and updated. I didn't update any owners, so that's, but if I were to to create a visit, for example, let's go ahead and do that. For one of these pets, right? Another checkup. What we should be able to see is the call to that particular controller endpoint is metered. And why is this taking so long? Add new visit. Did I not click on it? There we go. And so within 15 seconds or so, the time it takes for another call to the Prometheus scrape endpoint to pick up the updated metrics, and then the refresh latency of Grafana, you could see that this number has now been updated. Number of visits created just increased by 1, I think. Or maybe I clicked on it twice, and so I got 2. I'm not sure. Okay. So that's the Grafana monitoring, and that's great. And let's look at one last dashboard, which is Kiali. Kiali is another terrific dashboard. So maybe what I'll do is I'm going to call, if you look here, here I'm going to call a specific endpoint with different owners against the pet clinic front end service, because it creates a very nice visualization, which Kiali is known for. And so we're deploying Kiali, and that's going to take a moment. And once Kiali is ready, we're going to look at its dashboard. We're going to look at the visualizations that it allows you to see, something like this. Right, a call to that endpoint through the ingress gateway is then, you can see the entire call graph essentially, all the way to the database, which is really nice to see. And so that's what Kiali offers. It's sort of a bespoke dashboard. It's actually much more than that, but that's typically one of the highlight features of Kiali. And as soon as it comes up, we'll go and take a look at it ourselves as well. Mhm. It's not quite ready yet. Mhm. It's sure taking a while. There it is. Okay. All right, so this is the Kiali UI. We can look at the graph and point at the default namespace. There's a lot of information here to glean. Um, I typically like to show the security, toggle the security checkbox, which shows that all the calls between services is actually secure using MTLS. Um, and this is a live view of calls of the traffic that's going through my system right now. So great insight into exactly making sense of what's going on in my system. And I can look at my services. I can focus on, say, the customer service. I can look at um, metrics. I can look at traces. See maybe an outlier and latency here. We can look at I noticed that one of the things Kiali does is it also reads the Spring Boot standard metrics for the JVM. And so if you want to look at the JVM standard metrics, you get it for free here in Kiali without building your own dashboard or importing a Spring Boot dashboard in Grafana. Um, so a lot worth checking out. You can look at I like to look at the traffic rate or maybe sometimes traffic distributions. Um, Here you can see the number of requests per second being handled. You can also zoom in on a particular service and look at things from its perspective, um, whether requests into this service are healthy or out of this service or what have you. Here, maybe this is both in and out because this is the pet clinic front end receiving requests from the ingress gateway and then sending requests to the upstream services. So that's Kiali in a nutshell. So let's wrap up. So we've looked at observability. Maybe I'll leave this running. Doesn't matter. We've looked at observability in different ways, right? Distributed traces, metrics, how we collect them, how we expose them, how we set up dashboards through or reuse Istio dashboards for in Grafana or the Kiali bespoke dashboard, which is terrific. But if we sort of take a step back and sort of understand what we've got here, it's a system which, in my mind, is beautifully complementary. Spring Boot is a mature framework where they've really streamlined so many different things. The collection of metrics from inside your application or the propagation of trace headers was so easy to do. Spring Boot makes it such a joy to sort of code my application. If I look at, for example, any of these applications, um, you have your repository, Spring Data JPA, and the definition of the mapping with your objects in the database model, and the exposure of repositories, and how easy it is to write REST controller or expose specific application metrics. This just reads beautifully. It's very, very clean. A lot of power there, right? And that's my Spring Boot applications. And the good news is that the stuff between the microservices, dealing with a network, retries, timeouts, circuit breakers, load balancing. You don't need ribbon here. None of those Spring Cloud libraries are in sight. As a matter of fact, the end result of my work of porting these set of microservices um, to Istio is the complete removal and absence of Spring Cloud libraries and sort of a going back to basics and not needing to worry about what's between the cracks, right? The network and then the endpoints, so to speak. You're working on the endpoints. The network is Istio's job, and it's configured independently and orthogonally by maybe a platform operator, or again, maybe it's a responsibility that your development team still inherits, but it's completely orthogonal to your applications. You don't need to disturb your applications in order to apply, configure ingress, configure resilience. Observability is a big advantage in terms of the richness of all of the metrics that you obtain, not only from inside your application, but in terms of the calls between applications, is sort of exposed here by Istio and through Envoy. And so that takes me back to maybe something I point out in the introduction, which is a quote by a French writer that says that perfection is attained when there's no longer anything to take away. So Spring, essentially with Spring Boot, has sort of taken away a lot of craft in how you configure your application. But here I've taken away a lot of Spring Cloud libraries from my applications, and I've arrived at a steady state where my applications are just clean and clear Spring Boot applications that express their intent in terms of the features that they expose and the calls that they make to expose data or to ingest information and nothing more. And that sort of takes me back to sort of the conclusion. So if we were to wrap up this conversation, my main reflections is that most of my work involved removing code. All other concerns could be deployed and configured with Istio. And the best part is that the mesh configuration is truly decoupled from my application. All of these things that I can configure now through Istio. You get tremendous observability support out of the box, and Spring adds the ability to configure trace propagation cleanly. And Spring support for reactive processing is also something that I found rather interesting and intriguing here. So that's something maybe you ought to maybe take a look at as well. And that sums up the demonstration. So I hope you are able to go through this on your own. I have outlined every single step here through this sort of portal. The only URL you need to remember is the Spring Pet Clinic URL. Actually, you can even go upstream from this and go look at the Pet Clinic application website and look at the Istio fork, which will lead you to this page. You can check out a clone of this repository, follow the instructions through this portal here, and sort of build yourself, go through these steps on your own. Build yourself a Kubernetes cluster, deploy Istio, configure ingress, deploy your application, configure security and observability, and see all of this in action. I think it's rather compelling. Again, I'd like to conclude by saying thank you for your time and for your attention, and I hope you found this helpful. Bye.